All right, we're going to continue with 7.3. So this is still 7.3. We are simplifying radicals still, but now we're talking about variables and coefficients. So we got to do a little bit extra here. Not too much different though. So the very first step is to still simplify the radicand, what's on the number underneath the square root. So 40. I'm going to break down 40 into 20 and 2, 10 and 2, 5 and 2. I'm going to break down x squared. X squared is x times x. And the y to the third is y times y times y. Those are your prime variables. It's as small as they get. Just y times 1 is the only way to get y, and x times 1 is the only way to get x. Now I'm going to write this all out horizontally. Let me do this in a different color so we can see. We have 3 2's, a 5, 2 x's, and 3 y's. It is a square root, so we're looking for pairs. So a pair of 2's, that'll come down as a 2. Pair of x's, that'll come out as an x. And a pair of y's, that'll come out as a y. What's left over is underneath is a 2 times 5 and then a y. On the outside we have 2 times xy, we just write 2xy. On the inside is 2 times 5 is 10y. On number 10, we have on the outside, or we're going to break down the radicand, the number on the inside, so that's 9 times 5, 5 is prime, 9 is not, 3 times 3. X to the fifth means x times x times x times x times x. Those are your prime variables. A to the sixth is 1, 2, 3, 4, 5, 6 a's. Those are your prime a's. Let's write this all out. So it's 3 times 3 times 5 times 1, 2, 3, 4, 5 x's and 1, 2, 3, 4, 5, 6 a's. It is a square root, so we are looking for pairs. So a pair of 3's comes out. Now let's be very careful. This x to the 3x over here needs to come down first. That's 3 times x. We're going to bring this 3 down, pair. We have a pair of x's, another pair of x's, so it's going to come down. Each pair comes out as just 1 when it comes to variables. 2, it's all the same thing. A is going to come down. Another A is going to come down. And another A is going to come down. What is left over? What did I not pair up? We have a 5 and that hidden little x there. 5 times x. We need to multiply everything on the outside. So we multiply our coefficients. 3 times 3, those are the only coefficients we have, so that's 9. We're going to multiply our variables. X times x times x. You remember you have your exponents with like bases, you add them. So that's going to be x to the third. And the same thing with a's. You're going to add those exponents with like bases. The a's are like our bases that are the same. So that's a to the third. And on the inside, 5 times x is 5x. And there's your final answer. All right, number 11. Whew, this looks crazy. So underneath, to the 5th power, that means q plus 4 times q plus 4 times q plus 4 times q, oh my goodness, times plus 4, and another q plus 4. There are your prime numbers. Well, what happens when we group them? There's one group that comes out, so that's a q plus 4. Oh yeah, it's a square root. I keep on forgetting that. That's a square root. Another grouping comes out. And the last group does not, so that stays underneath. Since it is multiplied on the outside, we need to simplify. We're going to have to multiply. So q times q is q squared. Q times 4 is 4q. So we're double distributing. If you want to do the Punnett square, you certainly can. You do q plus 4 and q plus 4. It's the same thing. I'm just doing double distribution. So it's 4. So I did q times q is q squared. Q times 4 is 4q. 4 times q is 4q. And 4 times 4 is 16. Underneath the radical, q plus 4. We have our like terms. You have 4 q's and you're adding 4 more q's. You have 8 q's total. Wow, this is turned into quite a problem. There you go. But it's all stuff you guys are able to do. Right on the back, we have cube roots. This is the first time we've encountered cube roots, so we're going to break it down exactly the same. So it has nothing to do with the radicand, the number underneath. We're going to break that down just like we did. So 56 is 28 and 2, 14 and 2, 7 and 2. I'm going to write this out horizontally. So we have 2 times 2 times 2 times 7. This is a cube root, so we need groups of 3. Well, what happens? We have a group of 3. So that's going to come out as 1, 2. And then it's a cube root of 7. The 7 will come out. That'll be your final answer. All right, number 13. Oh my goodness. 512 is 256 and 2. That is 128 and 2. That's 64 and 2. 32 and 2. 16 and 2. Whoa. All divided by 2, so I'm going to keep going. That is a lot of 2's. Whoa. How many 2's is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. X squared means x times x. There's your prime numbers, so x times x. Y to the 4th means y 4 times, so they're your prime numbers, prime variables. And then we have z to the 3rd. So writing them out horizontally, this is a square root. It's got to be a cube root. All right, this 3 is kind of hiding out there, but it should be a little bit closer. But it's a square root. We're going to have to bring that 4x down. So 4x is going to be 4 times x. Then it's a cube root, so we need groups of 3. So we're looking at 1, 2, 3, 2, so that each group is going to bring a 2 out. 1, 2, 3, 2, so another 2. 1, 2, 3, 2, so another 2. The x's, we don't have enough x's to come out. We have 3 y's, so that's going to come out. And we have 3 z's. What's left on the inside of this cube root? There's no variables, or no numbers, no coefficients, because all the 2's got used up. We have x times x, and we have a y. Let's make sense of this now. So we have 4 times 2 is 8, times 2 is 16, times 2 is 32. 32, x, y, z, cube root, x times x inside, that's x to the 1st, times x to the 1st is x squared, y. All right, let's go backwards. So going backwards, so what do we got to do? To get a 3 on the outside, you had to have a group of 3. 3 3's. What is 3 times 3 times 3? That's 27. So we're going to bring that on the inside. Really what you got to do is you take 27 times 7. 27 times 7 is 189. So it's 189. That's got to be what's underneath. So the cube root of 189 will break down into 3 cube root of 7. Again, here we have a square root, so that means that it's got to be, to bring the 5 inside, we would have had to have a pair of 5s to bring it outside. So we really just got to do 5 times 5 is 25, times what's inside is 3, which is 75. So it's going to be the square root of 75. That is it.